So in this Taylor's theorem, the result of this theorem, it will be used in proving the conservation laws. Here suppose that if we have a function f which is a function of one variable x only, then this fx, if it is continuous function of x and its derivatives, that is its first derivative, its second derivative and all the next higher derivatives, they are also continuous with respect to x. And then if we increase the value of x and suppose small h is the increment in the value of x, then what will be the value of this function f at x plus h? It can be calculated by using the Taylor's theorem. And what is the definition of this Taylor's theorem? So the value of function f at x plus h, it will be its value at fx plus increment in x, that is h, multiply by its first derivative, that is f dash x. What is f dash x? It is curly f by curly x, plus h square by 2 factorial, double derivative of f with respect to x, and so on. Now its next special case is if this increment in x, that is h, if it is very very small, then its higher terms like h square, h cube, h4, h5, h6 and so on, they will be even smaller than h. So therefore we can neglect or ignore these higher terms. So if you will ignore these higher terms, then this equation 1, it will be reduced to fx plus h. It is equal to fx plus h f dash x. And what is this f dash x? It is actually curly f by curly x. So this is Taylor's theorem when h is very small. Now next special case is if our function f, if it depends upon two variables. If our function f is a function of two variables, that is x as well as y, then f will be represented as f x comma y. Now there will be increment in the two variables, and suppose increment in x is a and increment in y is b. So what will be the increment in f? It will be f x plus a y plus b. So what will be the value of the function f at x plus a and y plus b? It will be the value of function at xy plus a, that is increment in x, into curly f by curly x, plus b, that is increment in y, into curly f by curly y. So this is Taylor's theorem. In case of a function f, it is a function of two variables, so which will be used in the proof of conservation laws, that is law of conservation of linear momentum, angular momentum and energy.